Welcome, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen, workers of the world. Are you ready to learn surface area and polynomial multiplication? Guys, this is easy. This is fun. You're going to like this. And to make it even better, the problems that we're going to learn with come directly from the practice assessment. So not only will you be learning math, but you'll be getting some of your homework done too, just by watching this video. Let's dive right in. Okay, so looking here at this first picture, we're going to try to find the surface area of this thing. Well, what does that mean, surface area? What that means is the area of all the surfaces. Okay, so this is surface area, the area of all the surfaces. So you're not finding the volume, and what you're actually finding is just the area of each side of this figure, and this figure is called a triangular prism. So it's very, very simple. Let me show you what to do. I like to draw pictures, so what I'm going to do is deconstruct this triangular prism into 5 two-dimensional shapes. So we're going from 3 dimensions to 2 dimensions. I'm going to start by drawing these 2 triangles. So this is this triangle right here. Okay. Notice that it's perfectly mirrored on the other side of the triangular prism. So we'll draw another one, try to make it look very similar. Okay. Actually, we're trying to make it look identical. There we go. We've got our 2 triangles. And now we've got to get this rectangle in the back here. You see this guy back here? So we'll get that rectangle there, and we'll just use a rectangle shape for that. And basically your strategy is to just find the areas of each of these pieces and just add them together. So now we'll find this, we'll get this rectangle here in front. See this guy right here, he's a rectangle. And we can draw him the same way we drew the other one. Just about like that. And then we've got this bottom piece right here. This is kind of the floor of this shape. And even though that looks skewed in 3 dimensions, it's actually just a 2-dimensional rectangle, kind of a skinny rectangle like that. Okay. All right. So all we have to do is label all these pieces. Let me move this guy just a little bit right there. Okay. So remember, we'll transfer this right angle goes right here. And now let's label all the sides. So what do we know? Let's get blue going on. So the height of this triangle is 4 and the base is 3. Same thing here. They're mirror images, so they have the same dimensions, 4 and 3. Now this was the back rectangle that had a length of 12 and a width of 4. Okay. Now we're looking at the front rectangle. That had a length of 12 and a width of 5. And then the skinny base piece here, the bottom, that had a length of, okay, so you kind of have to transfer that length down. The length is 12 and the width is 3. Okay, quick review. In order to find the area of a triangle, you just multiply the base times the height and you divide by 2. So if we're working here, we'll do in green, base times height divided by 2. 3 times 4 is 12. Okay, 12 divided by 2 is 6. 3 times 4 is 12. 12 divided by 2 is 6. 4 times 12 for this shape, that's 48. 5 times 12 is 60. 3 times 12 is 36. All we have to do is add up all these areas and we'll be done. So over here in side work, we'll do 60, and then we'll do 48, 36, 6, and 6. And we're just going to add those up, and we don't need a calculator to do that. We can do it in our heads. 0 plus 8 is 8. 8 plus 6 is 14. 14 plus 6 is 20. 20 plus 6 is 26. So we write a 6 and carry the 2. 2 plus 6 is 8. 8 plus 4 is 12. 12 plus 3 is 15. So we write 156, and this is yards squared. And just like that, we're done. So that's the first answer, and we will, ladies and gentlemen, put it in the red box of correctness. Okay, brought to us by one of our great math scholars, the red box of correctness. So that is number 1. You can do number 2 by yourself. It's just like number 1. Let's move on now. We're already on to the second part here. Now, guys, I know you're looking at this and you're thinking, oh boy, we just got through with polynomial division, so this must be even harder. Quite to the contrary, this is way easier than polynomial division. Just wait till you see how easy it is. You're going to be totally blown away. Let's do a quick review and remember that area equals length times width. Okay, so in this problem, rather than giving you area, length, and width, it gives you these functions. Okay, they're conveniently labeled. It says if a rectangle has a width defined by w of x equals 2x plus 5, and the length defined by the function L of x equals 2x squared plus 8x minus 4, which function defines the rectangle's area. So basically, what it says is a of x, which just represents the area, is equal to L of x, which represents the length, times w of x, which represents the width. Okay, so we don't know the area. That's what we're trying to find. So it's a of x equals, now we do know L of x. L of x is 2x squared plus 8x minus 4. So we'll write 2x squared plus 8x minus 4. Now let's put that in parentheses so we don't lose track of it. And now we're going to multiply by the width, which is just 2x plus 5. So we'll write 2x plus 5, again in parentheses. So this is where it gets super easy. This is when we introduce one of our great friends in mathematics, the box. Okay, so we are going to draw a box that has 2 rows, ladies and gentlemen, and 3 columns. Okay, so here comes the row. We'll start with this row. We're just going to have to put one line right here to make 2 rows. And we want it to be right in the center there. So here goes our 2 rows. And let's spin this guy to 90 degrees. Maybe. There we go. And we're going to make 3 columns. So we just have to draw 2 vertical lines to make 3 columns. There's 1, and here's 2. You really should be doing this on your own paper, just so you can follow along. Once you understand this, guys, you are going to love polynomial multiplication. It is so much fun, so easy, much fun and much ease. So all we have to do is just look at this. You've got a 3-term number or function multiplied by a 2-term function or polynomial. Okay, so we're just going to transfer these pieces down to their columns. Okay, you're probably already thinking to do that. So let's choose a different color here. Let's put these in purple. So we have 2x squared plus 8x minus 4. Okay, like I said, couldn't be easier. Now this 2x plus 5 piece, that gets written on the vertical side. So we go over here and we write 2x and then plus 5. Okay. Now, all you have to do to fill out these boxes is just multiply the pieces together. All right. So the first thing we're going to do is multiply 2x squared times 2x. We will be doing that in side work, and we will be using blue. So over here in side work, we'll write 2x squared times 2x. Very important. This x has an exponent of 1. So everywhere we just see an x all by itself, put an exponent of 1. So let's zoom in a little bit on this, just this part. We're going to multiply 2x squared times 2x. All right, so the first thing you do is you multiply the numbers. 2 times 2 is 4. So that's the first piece, 4. Now, what do you do with these x's? Well, the product rule for exponents says that when the bases are the same, and these bases are the same, you just add these exponents. Okay, so what is 2 plus 1? Well, it's 3. So what that means is 2x squared times 2x to the first equals 4x cubed, or 4x to the third. 2 plus 1 is 3. Now, once you get that, you just write it here. We're going to write it here. 2x squared times 2x to the first is 4x cubed. Okay, moving on, we're going to go from left to right on the top row and then go down to the bottom row. The order doesn't really matter, but just keep it straight. We're going to now multiply 8x to the first times 2x to the first. So over here in side work, we'll put 8x to the first times 2x to the first. Okay, so here's the next part. So remember, we're going to start by multiplying the numbers together. 8 times 2 is 16. So we'll write that 16, get that down. And now we got to figure out the x part. So remember, you have the same base, so you just add the exponents. Easiest math problem in the world, ladies and gentlemen. Ready? What is 1 plus 1? 1 plus 1 is 2. So 8x to the first times 2x to the first is 16x to the 1 plus 1, or 16x squared. And that's a positive 16x squared, so we're going to put that right here, plus 16x squared. Ladies and gentlemen, we are ready to move on, and now we're going to multiply negative 4 times 2x to the first. All right, so over here in side work, we have negative 4 times 2x to the first power. Now, since the negative 4 doesn't have an x variable, this is actually way easier than the previous two. It's just 4 times 2 is 8, so negative 4 times 2, guys, it's just negative 8. And then that x to the first comes along for the ride. Don't forget him. And so we just go over here and write negative 8x to the first power. All right, so now we're on to the next part. We're on row 2, and so we're going to start by multiplying 2x squared times 5. 2x squared times 5. Let's write that in side work. 2x squared times 5. The second row is always easier than the first row because there's not a variable with that second number, so it's just 2 times 5 is 10. And that x squared comes along for the ride. 10x squared. So that's a positive 10x squared. I write the signs with it because I don't want to forget the signs. That's up to you. So 8x to the first times 5 is next up. So we'll write 8x to the first times 5. Okay, so there's no variable with the 5, so you just multiply. 8 times 5 is 40, and the x comes along for the ride, x to the first. So we put plus 40x. Final piece, ladies and gentlemen, couldn't be easier. Negative 4 times 5. Okay, I know some of you just did that in your head, but we're going to write it out. Negative 4 times 5. Well, 4 times 5 is 20, so negative 4 times 5 is negative 20. So that negative 20 sign is very important, goes right there. All right, you're almost done. You just have to draw 2 tic-tacs on this page. So here's our first tic-tac, and I'll explain how I come up with this. So why am I associating these two? What we're going to do right now is combine like terms. So what do I mean by like terms in the world of exponents? These exponents are the same, so those terms can go together. Similarly, you have 40x to the first and you have negative 8x to the first. Those have the same exponents, so since those exponents are the same, we can combine those terms together as well, forming another kind of tic-tac shape. All right, so here's our 2 tic-tacs. And so the underlying shape actually tells you what to do. You have to add these together. So we'll just go over into side work and we'll add those like terms together. This 4x cubed and this negative 20, they're going to be at the front and at the back of our final function respectively. So the 4x cubed is going to go up front, the negative 20 is going to go at the end, and the stuff we're combining is going to go in the middle. So let's go over into our side work here and just do a little bit of math, nothing too difficult, and we will be finished. All right, so here we have 16x squared and 10x squared. And guys, all we're going to do is add these two things together. So 16x squared plus 10x squared. The x squared just comes down. We're not going to mess with that at all. You're just adding 16 and 10. So 6 plus 0 is 6, and 1 plus 1 is 2. So this is positive 26x squared. So we'll remember that here for a moment. We're going to need him in a minute. Okay, we're going to need this, and we're going to eventually need that negative 20. So let's do the final piece and then string all those pieces together. We have negative, well, we'll start with the positive 40. We have positive 40x to the first, and then we have negative 8x to the first. Now, I wrote that 40 on top because what we're essentially doing is subtracting 8 from 40, right? You have 40, positive 40, and then negative 8. So because the bigger number is positive, we're going to just subtract. And the final answer will be positive. It takes the sign of the larger number. So remember, it's still going to be x to the first. We just do 40 minus 8. We have to borrow from the 4. That becomes a 3, and this becomes a 10. So 8 from 10 gives 2. And then the 3 comes down. So this is 32x to the first, and that's positive 32x to the first. Okay? So we need that piece there. And now, guys, all this is a stitching process. We're just stitching together these terms in a specific way. So I need to I'll go find some space to write our answer, and we'll write it up here. So our final answer up here is going to say a of x equals. Now, we're going to go in descending order of exponents. So like I said, the first x, the largest exponent is this cubed function here, this cubed exponent rather. So we'll write a of x equals 4x cubed. And then our next largest exponent is this 26x squared. That's positive. So just write plus 26x squared. And then the next term is this plus 32x to the first plus 32x to the first. And then remember I said that minus 20 would go on the end. So you just put minus 20. Now I want to show you something neat. Look at this. 3, 2, 1. It's like a countdown. Okay, so it's always going to be in that order. Biggest exponent comes first, and then it goes in descending order down to 1. Okay, so let's put the red box of correctness on this because we are done with that problem. And what answer choice would that be? Looks like it would be A. Okay. All right, guys. Well, I really do hope that you have found this to be pretty simple. That's all it really is. And so, like I said, this is easy. So thank you so much for watching. If you haven't already, subscribe to the channel. If you found this video useful in any way, please hit that like button. And if you haven't already, smash that notification bell so you're always alerted to new videos on this channel. Thank you very much.